All right, I apologize for the interruption. As mentioned already, I will be making a years and days counter as well as a 24-hour clock, all on a single IC. And before we begin programming in Stationeers, I want to actually plan out some of the code in Microsoft Excel. So the first thing I want to do here is I want to consider what our outputs will be. We want to have years, days, hours, minutes. So these are going to be our outputs. Now we will have two inputs. One input is a daylight sensor and the other is a switch. And the switch will dictate whether we want a 24-hour clock or a 12-hour clock. And I'm considering that if our mode is 2, if we have a second mode in here, we can probably employ a hybrid of a 24-hour clock and a 12-hour clock, one that will swap back and forth. It will continually toggle between the 12-hour and the 24-hour. But we'll get to that a little later. The first thing we want to do here is create a 24-hour clock. And so we want to think about how we want to actually do that. We will be keeping track of tick marks and converting tick marks into hours and minutes based on the number of tick marks that have occurred since midnight. And so every time the day reaches midnight, the tick marks reset to 0. So we also need to keep track of how many tick marks are taking place per day. So we can create a variable called ticks per day. So I'm just going to call this ticks per day. I'm going to zoom in here so you can see this. And so for a start, let's assume we have 700 ticks in a day. And then we want to see how many ticks we have. And let's say we've achieved, let's say 450 ticks. I'm off here. 250 ticks. All right. So we want to convert this into hours and minutes, right? And so we kind of want to separate the years and the days from the hours and minutes. And we can have another variable here. We can have I was going to say if we're counting days and we want to convert days into years, we might have a similar kind of thing going on here, but I think that's not necessary. Right now, the important thing is to calculate our hours and minutes, and we'll leave the years and days out for now. So let's say at any given moment we have 250 ticks. And there are 700 ticks in a day. We need to consider that a day has, I believe it's 1,440 minutes in a day. So we can say minutes per day is 1,440. And of course, minutes per hour is 60. Of course, these are constants. 1,440 comes from 60 times 4. You can see that here, that's 60 times, did I say 4? I meant 24. 60 times 24 is 1,440. 24 hours, 60 minutes, that gives you 1,440 minutes in a day. So we know that. And we need to convert ticks to minutes and hours. And this is, of course, per day, right? So we want to consider how many ticks are in an hour, right? And we know there are 24 hours in a day. So to convert ticks into hours, we can take our number of ticks and multiply that by 24 and divide it by our number of ticks per day. You can see here that 700 ticks gives us 24 hours. 500 ticks gives us 17.14 hours. And so we're almost done here. Let me move this over here. And let's update the algorithm. Now, of course, in Stationeers code, you cannot just write equations this way. So you might want to consider an alternative. We have to break this down line by line. So here's how I'm going to do it. I'm going to treat each next line below as if it's another line of code. So let's take this 500, we're going to multiply it by 24, or whatever our number of ticks are at any given moment. Let's say we have 273 ticks. And so this is the equivalent of our multiply. If this is a variable, let's say R0, this will be multiply R0 is equal to a number of ticks times 24. So the code might look like this. And we can choose any variable here. These are registers, of course. In the IC10, we have registers, but I'm just going to call them variables. And I don't really care what that variable is right now. But the next operation we want to perform is a division. We want R0 is equal to R0 divided by our ticks per day. And in Excel, we have this, and we want to divide that by that. And then we want to perform a truncate. So we want to truncate R0 so we want to truncate R0, and that will knock off the decimal. So this here is truncate that number right there. And of course, these are the hours. So then we can display that. So you can say S, hours, setting, that's R0. In this case, it's equal to the previous value. So imagine that this is a display. It's a console, or maybe it's a logic memory. So we've converted ticks into hours. Now we want to consider, well, how many minutes do we have? We can do a similar operation using a modulo instead. So we can multiply, let's call R1 here. And actually, let's say our number of ticks, that's R0. So we might want a different register instead of R0. But at this moment, I really don't care what I'm using. I'm just going to arbitrarily use a bunch of R1s here. And we can choose later on which registers we actually want for these blocks of code. So I'm going to create several similar blocks of code for our hours and our minutes. And then later on, I'm going to build the code that synchronizes our days. And I'm not sure if there's a way to do that in Microsoft Excel. I think that's something I'm going to have to do in Stationeers. So for the next line of code, let's say we're going to multiply ticks by 1,440. So that's how many let's see, that's how many ticks are in a day. Sorry, that's how many minutes are in a day. There are 24 hours in a day and 1,440 minutes in a day. And so here we're going to multiply the number of ticks by 1,440. And then we do a similar thing here. We're going to divide by the ticks per day. And we're going to truncate. Now we want to take the modulo over 60. And so we can now write minutes setting is supposed to be R1. And we see here that we have 17 hours and 8 minutes. So at 0 ticks, we're at 0 hours, 0 minutes. At 700 ticks, we're at 24 hours and 0 minutes. So let's say we have 699 minutes. Well, that's the same as 2357. So we have a working clock here. Now, let's consider how we want our clock to look if we want to use a a 12-hour clock. And so now we need another input somewhere. So I'm going to shift this over. Actually, I'm not going to do that. Let's have an input over here. Let's call it our mode. And our mode can be 0, 1, or 2. And of course, to get 3 modes, you would need a a dial. But the dials do not go down to 0. The lowest is a 1. So for now, let's just leave this at 0 and 1. So mode 0 is going to be our 24-hour clock, and mode 1 is going to be our 12-hour clock. So let's go ahead and move these down. We want to make some space for additional blocks of code. So let me copy this and put it up here. Copying does not work. Something's not right here. Oh, this is why. There we go. So we have 2 versions of the hour calculator. And we will need to modify one of them so that it accounts for our mode. Actually, they're both going to need to account for our mode. And there's 2 ways to do it. One way is we can use jump commands. We can skip around, skip lines of code, which is probably how I'm going to do it. But I cannot simulate that in Microsoft Excel. So what I'm probably going to do here for the time being is calculate both. So I can create, let's see, here's our input. We're either going to have a 0 or a 1. And then down here, I'm going to create 2 placeholders. Let's say is 24-hour. And this is 12-hour. So this is equal to 1 minus our mode. And this one is simply equal to our mode. As you can see, it's not going to work well. I could also use logical conditions. But for now, we're going to leave it at this. So I want to delete these statements here. And I'm going to assume we don't really need a second line here. Well, maybe we do. You do. Let me undo that. One of these needs to be 24 hours. The other needs to be 12. That's how we're going to do it. So this is going to be 12. However, in a 12-hour clock, we don't have 0 o'clock. We have 12 o'clock and then it's 1 o'clock, whether it's AM or PM. So we need to fix that over here. And one way to do that is to, let's see here, we want to do I believe a modulo instead of a truncate. Well, we can truncate, but okay, never mind. I remember how I did this last time. We're still going to multiply it by 24. Let's call this, let's see here, 350. Let's make it 350. So it's 12 o'clock. And if you want, make it 351. So it's 12:02. And of course it's PM. Let's go up a little bit higher actually. So to 300, 400. It's 1,300 hours. Actually, let's go low. Like maybe 10. So in a 24-hour clock, we can have 0. But in a 12-hour clock, we cannot have 0. We must have 12. So I need to think about how I'm going to do this. I can't remember how I did it the last time. I definitely used a modulo. That's for sure. Let me see what happens here if I perform a modulo. I'll just write it down here. So mod that over 12, it's still 0. However, let's modify this. I think we do not want to truncate it yet. We want to truncate it at the very end. This is our add R1 is R1 plus 1. This is our modulo 12. Let's move this up. We want to subtract. So right now this is a -1. This actually might supposed to be a -1. We're looking at the wrong side here. So multiply by 24, divide by 700, and then we add 1, and then we take the modulo, subtract 1, and then we take the truncate of that one. And it's still not working. So these might have to be swapped. So let's subtract 1 first, and then add 1 after the modulo. And there we go. So at all times, we have a 12 and not 0. So at all times, we have 12. Now, of course, let's say we have subtotals here. And this is going to be equal to a multiplication of, we're going to look at R2 here. We're going to have a different variable. R2 is equal to R1 times is 24 hour. And so maybe here we have, I don't know, R5, R6. So over here we would have R2 is equal to R1 times R6. But to get our point across, we're going to leave it as is 24 hour. And down here, we're going to have R3 is equal to R1 times is 12 hour. So here we have 24. We have this value, our subtotal times that logic statement. And down here, we have our 12-hour calculation times is 12 hours. Now we still have to create our final calculation. We're going to multiply. Let's just use R1 again. R1 is equal to R2 times R3. Or not multiply, we're going to add. So we're going to add the two finals together. So R2 plus R3. This will use our subtotal. So there we have it. This is our 24-hour calculation. And down here is our 12-hour calculation. So imagine that this is a switch here. By default, it's a 24-hour clock. And then when you change the mode to 1, we have a 12-hour clock. Now, some of these are repeated, so we can actually delete some of these lines of code. In fact, we can delete these 2 lines of code because they're the same. So we can theoretically take this information and duplicate it in Stationeers. So that's done for the hour and minute calculator. I want to move this to the side for now, or we can just move it down. And I want to go to the years and days calculator. And it's really simple. We can have our updating mechanism that, that increments ticks will increment days also. But how the days get incremented is based on the daylight sensor. So there's not much I can do in Microsoft Excel to simulate that. What I can simulate is calculating our number of ticks per day. I think that's what I want to go over next. I'm going to put this up here. Let's call this our 10 is ticks per day. Now, something to take into account, something to consider is over how many days do we want to calculate our ticks per day? Because, our ticks are discrete. There are no decimals with the number of ticks. They just count up in integers. But the day length might not be an exact number of tick marks. So there's some lost information. But we can minimize that lost information by increasing the total number of days. So let's have another variable. I'm going to use R0 for now, but we can always change this to something else. And let's call these big ticks. Well, let's not do that just yet. Let's have several variables. So let's say we want to calculate the number of ticks per day over the course of 7 days. So we can have, let's say, R11, R12, R13, R14, R15, R16, and R17. And these variables represent the number of ticks that occurred in each of those days. And let's say that when we initialize the clock, let's give these names. Day 1, Day 2, Day 3, Day 4, Day 5, Day 6, and Day 7. So we have 7 days. And initially, they all have 0 ticks. We're considering the number of ticks that occur in each day. And so every time midnight occurs, these values would get updated. But initially we have all zeros. And let's say after the first day, we count 700 ticks. And then after the next midnight, the 700 gets moved up 1. And let's say we counted 699. And then at the next midnight, these move up to the previous day. So we're always at day 7, no matter what. We could also do the opposite. We can have day 1 is now, and then we're looking backwards. We're looking into the past. But right now, I'm going to look into the past going down in our numbers. It really doesn't matter the order, but these will start updating upwards. And let's say we count, 701 on the third day. So these will continue to update, and they will shift over. And at any given time, we want to add up all these ticks together and divide by the total number of days that have passed by. So we might actually need another set of variables. Or let's have one more here. Let's call it, let's use, I don't know, let's use R18. Number of days. So at this point, we'll have 3. And at the next, after the next midnight, these numbers will move up. And let's say we actually count here 698. And now we've counted 4 days. So what is our total number of ticks per day? In terms of, in Stationeers code. Well, I mean, before we get to Stationeers code, we want to just do a general math here. But we're going to have the total number of tick marks that have occurred and divide by the number of days. And you can see that our average so far is 699.5. And let's say we move up the next day, these get moved up. 698. And let's say finally we count 699 again. And of course, 5 days pass by. And we can see that our average is 699.4. So the decimal point here, that will approach a better precision as the days go by. So we'll have code similar to this inside of our Stationeers code. And this will take place before calculating our clock. Now, to account for the change in midnight, we have to keep track of the solar angle, the horizontal solar angle. And we want to look at when the solar angle crosses over, when it resets. And it swings from, I believe it swings from negative 180 to 180. So let's create some variables here. Just for simplicity, I'm going to use, I don't know, let's use something we haven't used yet. R4 and R5. R4, R5. And let's say this is our current angle, and this is our previous angle. And let's say that R6 is midnight. And so let's say we got, I don't know, 270, that's not 270, 270 degrees. And the previous angle, I think if you have the horizontal daylight sensor facing to the sky, then we count down from 180 to negative 180. So we can't have 270. That's not a good number. So let's say we have, I don't know, 79 degrees. And because we're counting down, the previous one was 65 degrees. All right. We did not cross over midnight. So we need to create a logical statement checking that we just crossed midnight. Because midnight happens when the angle jumps back up to 180 from negative 180. In other words, when it has a positive change. Did I get this right? No, this is backwards. Let's say previously it was 79 and now it's 65. Okay, that makes more sense. So we're going to say if this is equal to if our previous is greater than our current? No. Our previous must be less than our current. So let's say we had negative 179 and it suddenly jumped to 165. We've just detected midnight. And of course, let's say one tick mark later, this moves up to 165 and this moves down to 153. And so you can see that when we go from a negative to a positive, when we have this positive change, we've just detected midnight. And so every time midnight is detected, these will get modified. So far, so good? All right. So at the same time that these get modified, these also get modified. Our years and our days get modified, or at least our days get modified. And our years just get modified as our days count up towards 365. So I think we have everything sorted out. I'm going to go ahead and save this for now. I don't know what to call it. Let's just call it, I don't know, Stationeers clock. All right, now it's time to go into Stationeers. And we're going to try to implement what we've figured out here. Also, another thing to consider is that every time we export the code, we want the clock to keep the previous values. We don't want it to reset the values. And that's very useful in case power goes out, or in case you have to make a little change. Now, unfortunately, when power goes out, you're going to lose some accuracy in your clock. But as we've shown here with this example here, in this block of code, over the course of 7 days, the accuracy will improve again. So it will fix itself over time. So let's go ahead and load our previous map, our previous world, and we're just going to use what we've already created in the previous live stream. We have a 24-hour clock going, sorry, a 12-hour clock going on here. and we want to make modifications to this setup. And right now I actually want to delete some of the code, but not all of the code. So we're going to keep the last component here. I'm going to delete this. Let's call this update ticks. I kind of want to start fresh, but not too fresh. All right. So I need to change some of my outputs here. We wanted to include a switch. So you have mode. We don't want to use that. Let's say switch D1. And we want to display the year D2 to display days, that'll be D3, years, days, hour, and minute. So right now, we can keep some of these. We have our tick, previous angle, current angle. I'm going to hold off on ticks per day here. So we have our number of ticks, previous angle, current angle. We also have our years. Let's use R3. Days will be R4. Hours will be 5. And minutes will be R6. So it's not quite the same as what we have in Excel. I'm not sure if we can go all the way to R18. We might be able to. Let's see here. Day 1 ticks. We want to use R11. Day 2 ticks. I want to use R12. Day 3 ticks. R13. Day 4 ticks. R14. So this will keep a history of the number of ticks in each day. Now we do want to initialize our number of days to 0. The move command that initializes our registers. And let's keep our 10 as our ticks per day. And let's use ticks instead of tick. So R0 is our ticks as normal. In Excel, we were using R1, R2, and R3 to calculate our hours and our minutes. We cannot really do that here. We need to change that up just a little bit. So let's go with we need to have some placeholders. Also, we need to consider our modes. We'll come back to it. We'll come back to it. So these three variables here, I can probably put them all onto one variable. So it's no big deal. So sensor mode 1, that sets it to horizontal. And we are reading our solar angle. And we want the port to face north, because at midnight the sun is north. And this command here, this is telling us to jump to line update if R2 is less than R1. Now we need to change that because we don't need to change it. Our previous angle is R1, our current angle is R2, and we said here that we detect a midnight if our current angle is greater than our previous angle. And the other way to put it is if our if our current angle is less than or equal to our previous angle, then we're going to skip some lines of code here. So let's call this block of code update days. So our days get updated every time we hit midnight. And so when midnight occurs, we need to update all of this information here, and we need to reset our tick. And then we also need to recalculate our ticks per day. So let's go ahead and do that. We first, however, we need to initialize our days here. R11 needs to be 0. R12 is 0. R13 is 0. R14 is 0. R15 is 0. 16 is 0. And R17 is 0. So they all start at 0. And again, we have to update the most distant, the one that's most in the past first. That has to be updated first. So we can use these move commands. We will move R12 into R11. So we move from R12 into R11. And then we move R13 into R12. And so on and so forth. Finally, after our 7th day has been moved into our 6th day, we need to set our number of ticks into our most recent day. And this is going to be our actual tick, our actual number of ticks. Right here, R0. So this will be R0. And after that, we reset R0. And we also have to update our total number of days. We're going to increment it by 1. And now we can actually calculate our days per tick. And again, we have these summations going on here. So this is not going to be easy. If we run out of space here, we might have to start sacrificing some of these days. So let's go ahead and do that. We wanted R10 to equal our average ticks per day. And so we're going to reset temporarily, we're going to reset R10 to 0. Or rather, we're not going to just reset it, we're actually going to overwrite it with an addition. So R10 is now equal to R11 plus R12. And then we're going to update R10 as R10 plus R13. So we're going to add all these values together. This is that sum function in Excel. And finally, after we add them together, we're going to divide. R10 is equal to R10 divided by R18. And so this is our average ticks per day. We can change the name of the lines that's going to go in here. The blocks of code that go in this empty space. We can change the title of that to something else. So far it's kind of looking like our Excel spreadsheet here. We're updating our number of ticks in each day, and we're also calculating our average down here. So now we need to consider our year. And for the year, counting how many years have passed, we'll simply divide the number of days. Well, we can't do that. We can't do that. I don't really want to use a modulo function. I actually want to use this kind of function up here. So I'm going to use a BGE. Or rather a BLT. So we're going to branch, let's see, let's call this calculate hours. And minutes. We're going to call this calculate hours and minutes. So if it's not midnight, we're going to jump to calculate hours and minutes. And over here, we have update years. If it's not the end of the year, we're going to skip update years. Okay, so we also need to actually keep track of the number of days that have occurred in the years. So this is not the same as this. Okay, so these are our totals and our outputs. But these are used for calculating accuracy. So we can do that up here. So let's say registers for calculating accuracy. Not calculating accuracy. Let's say calculating script. Registers for ticks per day. And we could actually say calculating. Very long label, but so what? I don't care. You cannot make spaces here. It has to be all one word. So these are all for the purpose of calculating ticks per day. So our number of days here is R4. We have R4 right here. So we actually want to also update R4. So both of these are days, but they're two different purposes. So if our days is less than 365, then we're going to skip the years calculation. So we're going to jump to this line. Otherwise, we're going to update our year. And I think it's R3. We're going to increment that by 1. So we're going to call this increment years. So I think that's finished for now. Let me go ahead and confirm this. And I want to create a new script here. Let's call this years, days, clock. For lack of better language, that's what I'm going to call it. I'm not very fancy at naming things. And of course, this should be years, days, clock. We don't have anything down here yet. We're going to leave this as it is. We're not using R7 at the moment. So let's go ahead and begin our hours and minutes calculation. Let me pull up Microsoft Excel. This is where we begin this information. But first we need to consider our mode. So we're going to load our mode. Let's see here. What is mode? Are we using mode? We don't have mode yet. So let's put it here. Mode. AM, PM. Can't use that, can I? R7. This is our AM, PM mode. 1 is equal to AM, PM. 0 is 24-hour clock. So R7 is our AM, PM. And we're going to load that with the value of our switch setting. Then let's go ahead and bring in Microsoft Excel. Here we were using R1, R2, and R3. But over here we need a different, we need to use a different variable or a different register. Let's choose, well, we cannot use 8, 9, 10. We cannot use R10. So I feel like I'm a little bit stuck here. And I will figure out a way out of this. Oh yeah, I did mention that while here in Excel, I'm calculating both I'm calculating both the 24-hour clock and the 12-hour clock. I mentioned that in Stationeers, I'm not going to do that. I'm actually going to use line jumping to save registers. So I can do a branch BEQ, branch to line something if R7 is equal to 1. And so we can do something like this. Calculate 12-hour clock. And up here, calculate 24-hour clock. And so if our mode is equal to 1, we're going to skip our 24-hour clock and go to 12-hour clock. And down here we could say calculate minutes. And at the end of this block, if R7 is equal to 0, meaning that if we're using a 24-hour clock, we want to skip the 12-hour clock calculation and jump to minutes. So in this block, we'll calculate 24 hours. Over here, we'll calculate 12 hours. So I could actually change this to hours, 24 hours, 12 hours. So there we have it. We do not need to use 3 variables. We can just use 2. Or yeah, I think 2, or maybe even just 1 variable. So let's use our 8, and we'll call this calculator. Is R8. Calculator will be used to calculate the hours as well as the minutes. So let's go back to our Excel spreadsheet. So this R1 will become R8 over here. And all we're doing is multiplying our ticks by 24. So multiply R8 is equal to ticks, and how many ticks we got? R0. R0 times 24. Now I did mention that these 2 lines of code are being shared by both calculators. So what I can actually do is put this earlier, not there. We could put it before the jumps. We also want to divide. Make this an R8. So R8 is R8 divided by ticks per day. Now I am not comfortable using aliases for registers because one time they were bugged. But we can use aliases for devices. So our ticks per day was R10. So we're going to divide this by R10. So we can create a new label here. Convert ticks to hours. Now I'm just going to put in a bunch of pounds here for major steps. It's just for the sake of organization. And this is also a major step, by the way. Even though our major step is just one line. Because we're updating the year. Now these are minor steps. And when I say major steps, I mean we're jumping around. We're skipping those lines. So, okay. So let's go ahead and fill in this information. Pull up Microsoft Excel again. So here we have we perform a truncate. And this is 24-hour. We're right there. So we don't even need this. We're already there. That multiplication is we're multiplying our hour calculation by the mode. If our mode is equal to 0, then we're multiplying it by 1. But we're not doing this like we have it in Excel. We're using line jumping. Index out of range. Why? Oh my god. Oh my god, I can't believe I did that. Stupid error. Oh my god, that's such bullshit. Just saved 2 minutes ago. So let me go ahead and reboot. I don't know why I had that error, but I don't trust it. I probably lost a lot of work. I should confirm and save more often. Hard lessons learned. And I was trying to clear the error. I was not trying to click cancel. But the error, the button, the clear button, was being overlapped with the cancel button. And so I ended up exiting out of the code. I ended up exiting out of the editor instead of clearing the error. It's absolute bullshit. So, okay, here we are again. What did we lose? God damn it. All right, I'm gonna load. What do we have? What did we say was R7? AM, PM. Our calculators are 8. There. So we're going to load R7, switch, setting. We're going to BLE. Oh, no, BQ, not BLE. BEQ R7 is equal to 1. We're going to jump down to 12 hour. That's not hour, that's cower. Here's 24 hour, 12 hour, and we wanted to perform a multiplication. Multiply R8 is equal to our ticks times 24, and then we will divide by our ticks per day, which was R10. It's a good thing I remembered what I did. I need my Microsoft Excel again. So we have this guy. Oh wait, wrong line. This is what we wanted. Just going to copy these line by line. Actually, this is not even needed. This is going to be R8. Oh, and we can update that. And then down here for our 12-hour calculation, we do a few additional steps. And these are all R8. Oops, except for, yeah, that's one that is R8 also. These are all R8. Can't I click at the end? And of course, if we're using a 24-hour, we want to, oh, we don't want to go back here. We want to skip the remaining actions. Up, we want to go to minute. One more block of code, minute. Now we want to calculate our minutes. Very similar fashion. Right. And these are all going to be, this is R8, this is going to be R0. Ticks per day is R10. Our calculator is R8, 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 R8. Finally, display minute is R8. Now we still have to update our year here, so we're going to set the display year is R3. Display years. Yeah, it's plural. These are supposed to be setting. We're changing the setting on the display. Last but not least, need to look at days. Also, our days need to reset at the turn of the year. So we need to reset this to 0. So we're going to go ahead and set our days. I think it's R4 to 0. Now I think the best time to update our days is to do it let's say at the beginning of our, or rather at the beginning of our update tick. So we could just do it down here. Display days, setting, and it's R4. So they don't all get updated in the same lines, but we can do it. We can do it in the order of years, days, hours, minutes. We can do it that way. If we want to do it that way, we'll just have to put it up here. And I think the code is complete for now. So I'm going to go ahead and confirm this. I do want to update my library. And I want to export this. And of course, we're flashing an error because we have not updated our hardware. Our daylight sensor is still good. We have the port facing north. And as the sun rotates, it goes from 180 degrees, counts down all the way to negative 180, and then jumps back up to 180. So we need to change out our hardware. We're going to have, I believe, 5 displays. So we need to find a way to fit that all in here. Get my authoring tool out. Let's add some frames. And let's color them black because black is cool. I feel like I'm missing a console. Oh well. I'm going to have to move these over because I need space for consoles. Actually, come to think about it, I don't need so many frames here. I'm going to go ahead and use small displays. Just like that. So this is pointless. So we said this is the beginning of our loop. Every major block that is getting skipped will have a long line of pounds. These are minor blocks of code, so I'll just use some pounds. Not going to go all the way out to the end. This is update previous solar angle, increment, tick. All right. Now where did my consoles go? All right. So we want these to be these LED displays. So here we have years, days, oh, whoops, I'm missing the mode. Silly me. Let's put our mode switch right here. Okay. And actually, let's color it. So make it yellow. Let's label it. 2412. This is years, days, hour, minute. All right, now we need to connect devices. Daylight sensor. This needs to be switch. Then years. Days. Hour. Minute. I still have an error flashing. Out of register bounds. All right, so here's what we're going to do. We're going to sacrifice one day. We're going to calculate our average ticks per day over the course of 6 days instead of 7. And to do that, our ticks per day will be our 9. And then we'll have to shift the rest of these down. This will be R16. Or what we could do is put our numbers of days as R10, and the rest of these can stay as they are. I think this works out a little better. Or we can swap these places so we don't have to do too many changes. So number of days is R9 and ticks per day is R10. So now I need to go back and update these registers because I'm using too many registers. These are all the same, except we're dropping 1 day. And our increment day here is R9. So everything that's R18 becomes R9. R10 stays R10. Ticks per day. This is out of range. I think that's the only change we needed to make. So you can see here our AM PM mode. It's our 24/12 mode. So we're keeping a history of 6 days. And we shift them at the change of midnight. We shift them over and we increment our day and we update our days. And then we also add up all of our total ticks and divide by the number of days to get our average ticks per day. And we use that information to calculate our hours and minutes. And I think this is ready. It's still 9:41. Still have an error. 9:41. Oh, this is why. You cannot put a colon at the end. The colon belongs to the label of the line. You do not put it in the jump. I'm not sure why we already have 8 days. That makes no sense. Every time I export this, the days change. And I wonder why that is. You know what? I'm just going to set all these. I'm going to initialize all these to 0. R2, R3 is 0, R4 is 0, R5 is 0, R6 is 0, R7 is 0, R8 is 0. Everything starts as 0. And now we shall see if the calculator works. For the counter and clock. So our hours are counting up very fast here. And that's because I reset my clock late in the day. And so there were only a few total ticks that added up before the change of midnight. Now I can switch this to a 12-hour system. You can see that it only counts up to 12 o'clock. Whereas in my 24-hour system, it's whatever number of hours. You could toggle between these two different modes quite easily. So the best time to update your clock is right after midnight. Otherwise, you might have to wait up to 6 days to get an accurate estimation of the length of the day. Because this is ridiculous. So that's what I'm going to do right after midnight. I'm going to hit the export button. Now this should be a 0, not. It should not be a 1. It should be a 0. I don't understand. Something's triggering it. So it might be this right here, but I cannot tell for sure. Need to check something on Discord real quick. It might be stuck on one day for some stupid reason. Nope, I guess not. We're supposed to only increment our days when midnight is detected. Something's a little funky here. So I'm going to reset this one more time right after midnight hits. So now I have to wait a full day. I have to wait until the next midnight before it updates. But see, this is weird. It's not updating the days. Oh, I know why. I know why. In the register of the IC, it's 0. But in the LED display, it's 1 because it's the display that's not getting updated. So that is what I need to change. So we need to also reset the displays here. So we're going to reset the display years to 0, display days to 0, display hours to 0, and display minutes to 0. Now it should properly reset display. Nope, it does not. That's because I forgot this setting. Okay, so it reset. Did midnight just hit? See, it's still not resetting the display. I don't understand why it's doing that. Something's not calculating properly here. See, it can't be this. Let's go ahead and move this down one. See, that worked. It just hit midnight, so I'm going to reset it again, but it still says 1. Why? I don't understand. The headaches of troubleshooting. So again, midnight is detected when R2 is greater than R1. Because our horizontal angle gets more negative. It goes down. So when it gets more positive, it means that midnight just occurred. When they're equal to each other, it means that we've just initialized. So at the very beginning, when our days is equal to 0, I don't like any of these. I think I know what could be causing it. I might need an initial yield. I think some of these devices require some kind of delay before setting them. Now I don't want to double yield, I just want to yield once. So I'm going to yield right before the beginning of our loop. Because when I reset the system, all these registers are 0. They all start 0. And without that delay, without that yield, it goes down to my set display and it's too fast. So there needs to be a small delay. As you can see when I export that, nope, that did not solve it. That is freaking weird. Is it 2 yields? Do I need 2 yields? Can I get away with 3 yields? Nope. It's not the yields. It's funny, because all day long I hit this and it does not change it to 0. It only resets to 0 when it's equal to 2 or greater. That's so weird. It only resets when the sun is going down. So our forest days. Here's what I can do. If R2 is greater than R1, then we jump to update days. And then down here, we're simply going to jump to calculate hours and minutes. So we're going to branch to update days if our current angle is greater than our previous angle. I feel like when I initialize, it runs through that update days a little, like it just bugs. It's just like a bug in the game. I think that might be the case. There might be a bug with the B LE code. So I want to make sure I'm not using it anywhere else. Now, as soon as midnight hits, I'm going to test this again. I'm going to hit the export button and see if I fixed it. Nope. Still there. Don't know what's going on. I can probably do a test to see if we're running through this. That's just weird. I can only reset it when the day is it's weird. All right, let's see if what happens if we move the yield just before. Let's try it this way. Because it might be a delay in the daylight sensor. See, that's still giving me 1. You could kind of tell the position of the sun by looking at the glare. And you'll notice that as soon as noon passes over, that days is going to reset to 0. And I'm spamming the button. See? Somehow it's tied to that. So I'm going to do something, I'm going to do a little bit of more troubleshooting here just to figure out what's stuck. And I'm going to go back over here. You don't want to display any hours yet. Or minutes. I want to display that information here. Or rather, over here. Let's do it here. Display. Minute is going to be R2, so that's our current. And this will show me the angle that's changing. It's going to be hour, and this will be minute. Current is always less than the previous. You can actually switch those around. Make the hour the previous and the minute the current. So in the afternoon, we see that our previous starts out as 0. Aha, I think I figured out the problem. We need to initialize our previous value as something that's highly positive, like 180. So let's go ahead and do that here. We're going to initialize our previous value as 180, positive 180. That way at all times, the angle is counting down. So as you can see, it's in the morning. I hit export and the day is properly resetting to 0. So it looks like I got that figured out of the. Looks like I got that out of the way, is what I meant to say. Sorry, I'm getting tongue twisted here. And yes, I pretty much only live stream on YouTube. All right, so it looks like I fixed the bug. So I'm going to delete this, uncomment that, and that. So our clock is basically complete. It just hit midnight. I'm going to quickly reset this to minimize the error, to minimize the uncertainty. Alternatively, what I could do is have the clock wait until midnight before running the calculation of the average ticks per day. But for now, let's look at the accuracy of resetting the clock shortly after midnight. we have to wait till midnight again. Oh, and since this is fixed, I need to update my library. So let's put it to a 12-hour clock. And if our clock is accurate, the sun should rise at 6 a.m. The sun rose just before 6 a.m. Or maybe it probably was 6 a.m. It's just I could not see it because of the mountain. But the real test is at sunset. At 6 p.m., the sun should set again. Looks like the sun set early. Which is okay. The clock is not very accurate at the moment. But as these days get counted, the clock should improve its accuracy. So at 6 a.m., the sun should come up, and it should be slightly more accurate than the previous day. Seems like it was off by 3 minutes. And the sun should set at 6 p.m. again. And it should be more accurate this time. It's set at 5:35-ish. And after 6 days, the clock should be as accurate as it will ever be. So it looks like the sun set at 5:42. So the sunrise and the sunset is, they're both gradually drifting towards a more accurate time. And it's been about it's only been 3 days. Now, what I want to do before I wrap this up, I want to include a check where when you first export the code to the IC10, it's going to actually wait until midnight before it begins calculating the um, the ticks per day. So on the first midnight after an export, it's not going to add up the days. All right, here goes. 6 o'clock. Looks like 5:43. So it's slowly becoming more accurate, but I think it's not getting accurate fast enough. So I'm going to create a check for that. Let's go ahead and sacrifice one more day. So we'll do this on a 5-day basis. And we do not want to apply any shifts on the first midnight because we get a false value. So here's what we can do. We can bring this to the top. We want to put a check that skips the shifting of our day count if we've recently reset the clock. We want to discard the first set of ticks that were counted before the first midnight. We want to discard that. So I'm thinking about how we're going to carry that out. I'm going to bring this to the end. So I'm going to call this pre-shift. And down here is going to be post-shift. And so between these blocks of code, we are calculating the average number of ticks per day, and we're also performing a shift. We don't want to do any of that on the first midnight. We only want to increment our output display here, our number of days that are being output, showing that we've actually crossed midnight, but we don't want to actually calculate any clock values yet. So this is where things could get a little tricky. So I could create a jump command here. So we're going to branch down to post shift day if, let's see here, we want to use R16 to tell us. So we're going to use a BEQ. So let's see here. R16 is equal to 0. This tells us that we just exported the code. And so we're going to skip all of this shifting. And we're not going to calculate our average ticks per day. But we will reset our clock ticks. And then, of course, down here, being that we just hit our first midnight, we need to set R16 to 1. And that will void this line. And after one skip, we will continue to calculate throughout. So let's go ahead and test this. And if this code is correct now, we'll wait for 2 midnights to take place, and after that the clock will be very accurate. But the additional days, because now it's going to calculate the length of the day over the course of 5 days instead of 6 now, it will gradually improve the accuracy as time progresses. So as the days go by, the clock will be even more accurate. But I estimate that after the first 2 midnights, the clock will it'll be accurate to within a couple minutes. Instead of like 15 minutes, it'll be accurate to like 2 minutes or 3 minutes. Oh, I'm getting an error. Line 51. What did I do? Oh, right, the colon. I forgot about that. Gotta watch out for those colons. Let's go ahead and reset that. No error. Now we gotta wait 2 midnights. And while waiting, I need to take care of something, and I'll be right back. All right, I'm back. Ah, so looks like it's working as expected so far. And here we go, 6 o'clock, the sun should come up. Very close to 6 o'clock. 5:56. Or it may have just been 6 o'clock. We will tell at sunset. Here it goes. Haha. It looks like the sun set at exactly 6 o'clock. Okay, so we're quite successful at this point. We're only off by 1 tick mark. And so the 5-day estimation is only going to improve that accuracy further and further. So it's a success, and I'm quite happy. Now, I did mention that I want the clock to read the day and the year. In this way, we want to see if we can manually set the days. So if you started playing and you don't have this clock system going on yet, and let's say you keep track of how many days you've been playing, by the time you make the clock, you want to update your day count to what it actually is. You cannot do that with just the display alone, right? So maybe we want to use a memory, some kind of external circuit. But for now, I want to challenge myself here to being that when I export the code, it might reset the hour and minute clock, but it will preserve the years and days. That way, as the clock is running, you could just update your date. And if you do an export, you want to refresh the code, it's not going to mess up how many days and years you've spent in the world. So I'm going to go ahead and play around with that code a little bit. And to do that, I need to read our years and our days. Again, our years is stored in R3 and our days is stored in R4. So all I really have to do is go up here to the initialization and load R3 is display years setting. And then I do the same thing for R4. Display years setting. And so now every time I export the code, it'll reset the clock and it will reset the calculation, but it will not reset my days. But before I trigger that, I want to verify that my sunset is still happening at precisely 6 o'clock. It's not precisely 6 o'clock. It's drifting. Is it drifting? It's not good. Anyhow, let's go ahead and export this. It should preserve my 4. Nope. Does not work that way. Oh, this is why. This is supposed to be days. My bad. All right, now it should preserve the 1. And it does. So now let's try something a little different here. Let's go ahead and add some logic memory. I want to be able to manually set my year and month. Maybe I'll do it on this side. Not year and month, I meant year and day. Logic IO. I'm going to use a logic writer. Yeah, I don't really like this. Bad practice. Okay, this will work. Oh, going the wrong direction here. Don't want that down there. Like this. Okay. Now we shall call this. Let's make this one year. This one day. Put setting. Setting. All right. Now I'm going to change these to logic memories. So this is going to be logic memory year. This will be logic memory day. So we have a 3, 0. And when we export this, it should preserve the 3. And it does. Resets the hour and the minute, but it preserves our 3 because it reads this from here. So if I update this and set our time, it's refusing to budge, which means I cannot update it in real time. I need to look at those values at the beginning of the loop. So we're going to continuously read. So we have continual update. So we no longer need initialization. We'll read the value of our years and our days from the setting at all times. Export that. And now I can update my years. It's working. So I can fudge in my years to any value I want. Fudge in my days. 204 days. 304 days. 364 days. And so, if everything's programmed correctly, at midnight, this should cross over. This should spill over to 5 years, and this should reset back to 0. Ta-da! It worked. So you can always adjust the date. It's just like a real clock. Or a real calendar. All right. Now, I need to figure out why the clock was drifting to become inaccurate. Worst case scenario, we'll have to get rid of the 5-day, what do you call it? We have to get rid of the 5-day estimation. Something's drifting in there that's not right. And it might simply be that it's not adding up the tick marks correctly. Twelve, 13, 14, 15. Those are all getting shifted. Then 11, 12, 13, 15. Those are getting added correctly. Can't think of a reason for it to work. Under the clock, it's 9 p.m. So at 6 o'clock, the sun should come up. We always do this in 24-hour mode or 12 hour. Sun came up early. This is weird. Do 24-hour mode. Clock 1300. 2 o'clock 14. At 1800. Sun shall set at 1800. Nope, it sets late. absolutely weird. Why might it be rising early and setting late? Change my years. I've been on Mars for negative 100 years. "24-hour mode, 12-hour mode." I love it. So 6 o'clock it should set. Early or late? Too early. Why? I'm beginning to think that the calculation of just the first day is enough. And that somehow there's a little error that just keeps adding up. And I think it might have something to do with the missing tick mark. Missing tick. I think a tick is getting deleted. So I'm going to try resetting the tick mark. I'm going to try incrementing one additional tick mark at midnight. And then reset it. So I'm going to perform that right here. Add R16, not R16, it's R0. It's R0 and 1. And hopefully I'm doing the right thing here. Let's put a comment here. I'm going to call it reimburse lost tick. sun's coming up. We don't know anything yet. Ooh, exactly 6 o'clock. The sun came up. Might be onto something. Take it. Seems like it was still 15 minutes early. I mean, the sun came up at exactly 6 o'clock. See if it repeats it. Seems like it's pretty close to 6 o'clock. It's hard to tell. The only thing I could do is wait a few days and see if the clock is getting more accurate or getting worse. But I feel like if the system is not stable, then maybe it's just best to calculate the day, sorry, to calculate the ticks per day every day. Except for, of course, the first midnight. So far, it seems to be pretty accurate. I think the sun comes up as soon as you see orange. Another way to tell is when the solar angle reaches 0 degrees, that will tell us our time. All right, so the last thing I'm going to work on right now is a way to track the accuracy. And I need to think about how I'm going to do that. Maybe I can temporarily sacrifice R16. Or maybe not. Yeah, I'm not going to do that. So here's what I will do. I will only display the minutes when the sun reaches high noon. So I go down to here, and I will do a branch. Let's see. Yep. Okay. I need to sacrifice one of these registers temporarily. I need to decide which one to sacrifice. I'm going to temporarily sacrifice R8. So I'm going to write temporary test. And we're going to take the absolute value of not R8, but of R2. But we're going to use R8. No, this kind of sucks. I really can't do that. What can I sacrifice here? I'll sacrifice the year. That's what I'll sacrifice. Forget the year for now. R3. R3 is equal to the absolute value of R8. And we're going to branch to update ticks if the absolute value of our horizontal solar angle is less than, let's make it 5 degrees. So at approximately 5 degrees away from noon, we want to display our minutes. So we're going to track the accuracy of our clock at noon. So I'm going to confirm this for now. Let's go ahead and export this. The sun is coming up at 10 o'clock. This is very bad. That's still displaying the years. So that actually doesn't sacrifice it. Interesting. All right. Wait till the sun comes up, and then we're going to wait till noon. It missed it. Let's make this bigger. Let's make it 15 degrees. I know that's really bad. 15 degrees, that's the angle that the solar panel is at its maximum or minimum. So maybe 15 degrees is not good to use. We'll go with 10 degrees. But then again, we're looking at horizontal angle and not vertical angle. So 15 degrees might not be that bad. Well, I have another idea. What we can do is not take the absolute value. Oh, we're using R8. I got this backwards. We're supposed to be using R2. There we go. So if R2, while it's negative, let's make this 0. So while it's positive, okay, so it starts negative and it goes positive, right? Or do I have that backwards? It starts positive and goes negative. So while it's positive, we should be updating the display. That way, as soon as noon cuts off, the the minutes stop. So this should be less than or equal to, or just simply less than 0. Let's do it there. Look at this, 6 o'clock, and the sun is nowhere to be found. This is irritating. Just want to check the accuracy. That's all I want to do. Remember, this is one giant experiment, so it's expected that there's a lot of waiting around for time to pass. Okay. Goes. So at 11:50 we reached noon. So every half day the clock drifts early by 10 minutes. We're learning something. What happens if we don't reimburse this? Man. So it's been several, I bet it's been several months of game time. That. Eat my screwdriver. Huh. Exactly at noon, exactly at 12 o'clock, the sun reached the peak. So I guess I'm not supposed to add one tick mark to each day. And if that's the case, I can just leave it at R10 is equal to R0 at midnight. Let's see if the clock drifts on the second day. It's early again. Yeah. And then noon happens at 11:44. It's going out of whack. Okay, it's time to make some major changes here to the calculation. So we've already figured out that the most accurate ticks per day is the first full day that it completes. And beyond that, it loses accuracy. So we're not going to do any of this shifting at all. All we will do is calculate directly. We will say that R10 is equal to R0. And that's our ticks per day. And it gets updated every day. So all of this disappears. No reimbursement. Call this post calculate ticks per day. And it doesn't fit. Let's call it something else. Pre ticks per day, post ticks per day. How does that sound? Still doesn't fit. Okay. Pre ticks, post ticks. Yeah, whatever. I don't care that the comment doesn't fit. Let's go with this. Now let's check our accuracy. Fortunately, we gotta wait 2 days. So at 11:48, it hit noon. So there's always some degree of uncertainty here. And I want to say that probably the reason our clock starts drifting out of whack is that uncertainty adds up. And by chance, it just happens to become chaotic. So I think it's best just to calculate the number of ticks per day just simply on a daily basis. Every day, update the value. Let's see if the sun rises at 6. Close enough. I think with slower days, the clock will be more accurate because we have more ticks per day. So that's a little closer that time. 11:53. It's not bad. So let's bring our clock back to the way it was before. We don't need this temporary stuff. And we never needed this, apparently. We don't need all these teenagers except for 16. And I think this is everything. Don't need any of this. We don't even need that. And this is not a 24-hour clock. This is our year day clock. Let's overwrite that. And if you want to copy this code, go down the list slowly. And you can pause it at any time. Write it down. Copy. So far, this is the best working code. I hope you caught all that. And I will run through 2 more day cycles, and then I will stop the live stream. So again, this lets you update your days at any time. Even when you export the code, it does not overwrite the days and the years, but it will automatically update the days. So I'm 200 years old. I've been stuck on Mars for 200 years. Or 900 years. And this is a Julian calendar, so days roll over. Did it not roll over? Right. You know what? 364. 365, it will roll. Good, we have 24 and 12. 24-hour clock and 12-hour clock. Oh, and by the way, you can take off the computer. The IC will still run. Not sure if you were aware of that. So it's 12 a.m. I would really like to see this clock running on a normal day. That is with the default day length. I bet it would be really accurate. Accurate to the minute. And that's the clock. Keeps track of days, years. Whoops. Oh, nice. You can change the color. Huh. All right, well, I hope I did not bore you to death. Now, again, you don't need the logic writers and the memory. You can hook the ports directly to the consoles. The only disadvantage with connecting it directly is that you cannot manually update the years and the days. And make sure you do not run out of power during midnight, because then you'll lose days. So there you have it. And that's it for today. Hope you learned something. And I'll see you on the next live stream.